Welcome to the video on equilibrium. Some reactions are what we call reversible, so they can go in either direction. So here, if you look, so far we've just seen a single reaction arrow going from left to right. So CO combines with water to form CO2 and H2 and hydrogen gas. Okay, some reactions are reversible, meaning that the reverse reaction can also occur. Hydrogen plus CO2 can yield CO plus H2O. Okay, so the reverse reaction proceeds to the left and the forward to the right. Okay, so we've been looking at that forward reaction. If a system is at equilibrium, or a chemical reaction is at equilibrium, the rate of the forward equals the rate of the reverse. So this is very, important here. Okay, it doesn't mean that you have the same amount of reactants and products. Okay, so we'll look at how we can tell which one's favored here shortly, or if it's favored. But when it's at equilibrium, then the net concentrations of the reactants and products doesn't change. Okay, so when it's at equilibrium, it doesn't mean the reaction's stopping. It just means the forward and the reverse is at the same rate. Therefore, you're getting the same amounts of reactant and products at that point. Okay, doesn't mean that the reaction stops. So the relationship between the concentration of the products and of the reactants, okay, so how much we have of either of those, so which one is favored. So if we have this reversible reaction, okay, well, that's not necessarily a good thing if I'm wanting to form all product here on the right side. Okay, so how do I know which one's favored? When I do this reaction, am I going to get more products over here, or am I going to get the reverse reaction to proceed? So what I can do to determine this is I can calculate an equilibrium constant. Okay, I'm just going to show you in this video what the equilibrium constant is, and then in the next video we're going to do a calculation of it. The equilibrium constant is called K. It's also known as KEQ. You'll see it that way sometimes. Okay, and here when we see brackets, this symbolizes concentration, how concentrated is the reactant or product, and we use moles per liter, and this is called molarity. Okay, that's what we plug in wherever you see brackets. Okay, so we have this general reaction. A plus B yields C plus D. Okay, these lowercase, those are the coefficients, so that's the number out front. Okay, it could be anything really. Okay, to calculate an equilibrium constant, K is equal to the concentration of the products raised to the power of their coefficient. Okay, so their coefficient is in the balanced equation here. Okay, we have an equilibrium reaction because we have two arrows, forward and reverse, divided by reactant concentrations raised to the power of the coefficient. Okay, so let's see this in an actual example where we have compounds. Okay, so equilibrium constant equals K. Product concentration, so here we just have one product, okay, raised to the second power. The 2 goes here. Okay, so it's not times 2. In your calculator, you've got to put to an exponent to the second power. Okay, K is products over reactants. Okay, we have 2 reactants. Therefore, we have to plug in those concentrations. Right now, we don't have values in here. We're just looking at the form and how we would just start out trying to write out the equilibrium constant. Okay, so we plug in nitrogen. Okay, it's raised to the first power because we just have a 1, and we have a 1 here, so an understood 1 here. You do not have to write those in. Okay. And so the coefficient becomes the exponent. Okay, so that's what you see there. Okay, so what does this mean? That's what this video is about. Okay, what does equilibrium constant mean if we have an equilibrium reaction? So this is what's important. Okay, if K is greater than 1, then that means that the equilibrium lies to the right, meaning it favors the forward reaction and favors the products. Okay, this is the direction that we've been looking at in all of our other examples and videos up until now. Okay, and that means the product concentration has to be larger, because that's how the calculation would work. If you divided and the products is larger, you're going to get a number greater than 1. If K is much less than 1, that means you have more reactant concentration, and therefore the equilibrium lies to the left, meaning it favors the reactants. Okay, so if you look here, if K is around 1, then that means that you have about the same concentration of both. Okay, so the equilibrium's not really, it's balanced. It's not really shifting to the right or to the left. Okay, and I do want to reiterate what this means. So if a reaction is greater than 1, K is greater than 1, so the reaction favors the right. This means that I'm going to form more product, right? If it's going in the forward direction, I'm going to have a higher concentration. I'm going to have more water molecules, more product. Okay, that's what that means. Okay, and then of course the reverse would be true. Okay, so here we have a specific reaction. I already kind of went through it a second ago, but the K, our equilibrium constant, that's what K is 2.9 times 10 to the power of 82. So that's a really large number. So K is much, much larger than 1. Therefore, this is product favored. Okay, so its equilibrium lies to the right. And sometimes you'll see this. Okay, so the double arrow, it shows it's an equilibrium reaction, but this arrow is much larger because this reaction favors the products. Okay, if K was less than 1, then the reaction would favor the reactants. Okay, so if K is greater than 1, so K is equal to product concentration over reactant concentration. Okay, and these are raised to the power of the coefficients. I just put P and R there for coefficients of products and coefficients of reactants. Okay, if K is much greater than 1, the equilibrium favors the products and lies to the right. If it's much less than 1, it favors the reactant and lies to the left. And if it's around 1 or at 1, then both the reactants and products are at equilibrium. So they're about equal. And the next video, we're going to look at how we can calculate this. So all we're going to do is just put in numbers, put in concentrations, and solve for K. All right, thank you.